Hello everyone, welcome back. In this session, we are going to see about state space search. In our earlier sessions, we have seen about the artificial intelligence history and also different types of agents and the applications of artificial intelligence. What is a state space search? So state space search is a problem solving technique which is used in artificial intelligence to find the solution path from a starting node to the goal node. So by exploring various states, that is, so in every problem domain we will be given a state, that is a initial state. So in that initial state we will be given some set of whatever the characteristics are there for that problem, there will be given. So based on the problem domain and also based on the characteristics, we will explore from one state to another state. So and we will continue this process until we have find out whatever the goal node so that is present. So we have to reach that particular goal node. This state space search algorithm will searches the particular problem domain for the all the possible states of the problem to find the solution. So the applications will include the game playing algorithms to the natural language processing. The features of the state space search algorithm are exhaustiveness, completeness, optimality, and uninformed search. So this state space search algorithm, so for exhaustiveness, so this state space search algorithm will find out the whatever the possible ways that they're present for that problem domain. So it will searches all the possible ways to find the optimal solution. And the completeness, so for every problem domain, if any solution is present in the for that particular problem domain, then this state space search algorithm will guaranteely find the solution. Optimality, so after finding the solution, so this particular state space search algorithm, whatever the algorithm we are going to use, so for that particular problem domain, so if particular solution is found means that particular solution will be the optimal solution. And also uninformed search, so for this one, so whatever the algorithm we are using for this state space search algorithm, they will come under uninformed search. That is, so for this searching problem, so whatever we will be given is the starting node and the goal node. So we have to go from one state to another state until the goal node. So we will not be provided any added information, that is, so whatever the step we are taking and whatever the state we are exploring, is that particular state is the correct state to go to the goal node or not, that information was not known to the particular user. So that he have to explore all the possible ways to find out the goal node. So this was the basic thing about the state space search. State space search algorithms will be represented using this mathematic notation, that is, so state space search equal to, so s comma a comma action of s comma result of s comma a and cost of s comma a. Here s is the set of all the states, and these states will include, so the starting state and goal state and also various different states that are present in the particular problem domain. So whatever the states that is present in problem domain, so they will come under S. And the A is the set of all the actions that can be performed in the particular problem domain. They will all come under the, so A. So next one is the action of S. Action of S is a function in which for that particular, here the argument is the S. S is a state. So some state, let's say some state S. So this particular state S is given as input for this action, and this particular function will give the output. Let's say it will give an action that can be applied on that particular state S. Next one is the result of S comma A. That is, so we are for this function we are giving, so state S comma S as input, and also, so next one is the result of S comma A. So here the arguments are state S and action A. So this state S is the particular state. For that particular state we are going to apply action A. So by applying action A, so what is the result for the particular state S? So it will come as the output for this result function. Next one is a cost of s comma a. So for doing an action a on state s, so whatever the cost it is taking, so this will be the output for the cost of s comma a. Here we can see the working of state space search. So initially we are before going to the working, so for every we will try to solve different problems in the state space search algorithms. So for this state space search algorithm, for example, some problem is given. So for that particular problem, we will be given an initial state and also a goal state. That means we have to start from the initial state and we have to go to the goal state. So this is our main problem domain. So for this problem domain, we have to follow this state, all the state space search algorithms will follow the, so this working. So in this working, so first the states will be initialized here, and so whatever the initial state that is present, it will be set as a current state. So in the now the current state will be consisting of a, it will, let's say it is a queue. So in that queue now we are having only one state, that is a initial state. So first we will check whether that initial state is a goal state. If that particular whatever the initial state, if it is a goal state, then we will say our searching was successful and we will return the solution. But so what happens if the particular state is not goal state means, so we have to generate all the reachable states, that is all the neighboring states of that particular state, and we will, for every neighboring state, we have to check whether it is already visited. That means already it was processed or not. So whether we have checked for whether it is a goal state or not, so that one will be checked. And if particular whatever the node is already visited, then we will skip that particular state, and we will again going to check the same for the all the remaining states of the current state. So we will for all the states we will check this visited column. So who are the states which are not visited, they will be added to the current state queue. So again this process will continue until we have find the solution. So first let's say we are starting from initial node. So let's say we are having a problem statement of, so let's say I am having S and G. So between S and G we are having so three different states, so A, B and C. So my problem domain is I have to travel from so A to G. Let us have a small example for this working. So here we have given some graph, example graph. In this graph we have to travel from S to G. So for traveling from S to G we are having so three different childs are there. So S to A, S to B and S to C. So initially we will start from the starting state S, and this starting state S we will first we will check whether it is a goal state. So S is not a goal state. So what are the reachable states from the S? That are A, B, C. So these A, B, C will be so fetched here, and for A we will check whether it is visited or not. So it was already it was not visited. So this current state now will be containing A, and also next B is also checked whether it is already visited. So B is also not visited, so B also will be added to the queue. Next C is also checked whether it is visited. So we will check C is also not visited, so C is also added to the current state queue. So next time, so we will try to get any element. So here now we are having so three different states in the current state queue. So in from those three states I will select any state and I will check whether it is a goal state or not. If it is a goal state, then we will return the solution. If it is not the solution, then we will generate all the reachable states for that A. So for A the reachable states are S and G. So again S and G will be checked. So for this S and G, for S we will check whether it is visited. Yes, it is visited. So we will skip this S. Next G. So G we will see whether it is visited or not. G is not visited. So G will be added to the current state queue. So similarly this process will continue until we have find the G, and we have tested so goal condition on G. So until this particular step, so this process will be repeated. So this is the working of a state space search. Some of the examples of state space search are 8 tiles problem and man-goat line problem, water jug problem, and n-pin problems. So in this one, first we will see about what is the 8 tile problem. So in this 8 tile problem, we will be given 3 by 3. So total 3 by 3 matrix. In that matrix, we will be having 9 cells. So in that 9 cells, we are going to place 8 digits, and also we will kept 1 digit as a blank space. So for this particular problem, here we can see it is the starting state and this is the goal state. So initially the configuration of the particular 8 tile will be like this. So here 1, 2, 3 are placed in the first row, 5, 6 and a blank space is placed in the second row, and 7, 8, 4 are placed in the third row. So we have to go through some. So what are the various states present for this particular tile, and we will try all the possibilities until we have find this goal node. So this is our main problem domain. So by using state space search algorithms, we already stated we are going to apply brute force technique. That is, we have to search all the possible values for the particular 8 tile problem. So let's say this is some state. So for this particular state, so in the first row we are having 1, 2, 3, and the second row we are having 8 blank space and 4, and the third row we are having 7, 6 and 5. So so this is the intermediate state. So for this particular state we are having 4 types of operations. So we can see, so 8 here. So this 8 can be, so 8 can be moved to the blank space, and the blank space then it will be moved to the 8th position. So that is one state. And also we can have, so 2 can be moved down, and also 4 can be moved to left, and 6 can be moved to up. These are the 4 possible states for this particular state. So we have seen that one only. So in this one, so 2 was moved down, and this state 4 was moved left. For this state 6 was moved up, and for this state 8 was moved right. So these are the possible states. So by using this, so for this particular state, so these are the reachable states. So in these 4 different states, we can select any one state. So by using this state based search algorithm, that means, so one person can select the first one, so one person can select this one person can select this one, and one person can select this one. So these can be, so can be selected, anything can be selected, it was okay. So for this particular state, again I will check what is the reachable states. We will check whether it is a goal state or not. So clearly it is not a goal state. So we will apply what are the reachable states. So for this one, so we are having 3 different moves. So 1 can be moved right, and 3 can be moved left, and 2 can be moved up. So by moving 2 to up, then it will be the same initial, whatever the state is there, it will come. So we will skip that one, and we will only have the what are the 2 reachable states. So that is 1, 2. So 1 can be moved and 3 can be moved. So those 2 can be seen here. So similarly, this process will continue until and unless we have reached our goal state. So whatever the goal state in the problem, they will give some goal state. So until we have reached that particular problem, so that this process will be continued. If a solution for the particular problem is there, this state space search algorithm will guaranteely find it. But it will find, but it will take some time. So if time is not an issue, we will go for the state space search algorithms. So this is one procedure, this is one processor, this is one processor, this is one processor, this is one processor. Like that we can have so multiple possible ways. So to achieving the particular whatever the goal state. So this is the 8 tile problem. So these other examples of the state space search algorithms are man-goat line, cabbage problem, water jug problem, and n-pin problem. So I will specify the whatever the problem statements. So for that man-goat problem, So we will be having a river. So in the, let's say this is an left bank and this is the right bank of the river. So in the left bank we are having a man is there, a lion, a goat and a cabbage are there. So the problem statement here is I have to travel these four objects. So these four objects I have to travel them from the, so these man, goat, lion and cabbage, so they are presented in the left bank and I have to move these four objects to the right bank. So we are having a boat here. So this boat will be having a minimum space, that is, so it can hold two objects, that is it can hold either man and lion or man and goat or man and cabbage. So for there are some clauses for this problem, that is, so without the presence of man, if man was not there, so in the presence, so if lion and goat are left alone, this lion will kill the goat. And also without the man, if goat and cabbage are left alone in any blank, then goat will eat the cabbage. So these are the two challenges we have given for this particular problem. So by not going into these conditions, we have to travel, so this man, lion, goat and cabbage to the right bank. So this is the problem statement of the man, goat, lion, cabbage problem. And also for the water jug problem, we will be given, so 3 jugs. So in water jug problem, we will be given 3 jugs. So one particular jug will be 8 liters and another jug will be 5 liters. So for the water jug problem, so here there will be 3 different jugs will be present. So first jug will be of the size 8 liters capacity and the second jug will be of 5 liter capacity and the third jug will be the, so 3 liter capacity. So we initially we will be having 8 liters of water that will be present in the, so 8 liter jug. So without using any other vessels, so we have to separate 4 liters of water. That is the problem domain here. So by using these 3 vessels, so that is 8 liter, 5 liter and 3 liter, we have to measure exactly 4 liters of the, so 4 liters water. So that is one problem statement. And also the third problem statement is the n-queen problem. So in this n-queen problem, we will be having an n by n matrix. So in that particular n by n matrix, I have to place n queens so that no queen can attack other queen. So that is, for example, if we are taking an 8 queen problem, so we will be given the chessboard, that is 8 into 8 matrix. So in this particular chessboard, we have to place 8 queens in that particular chessboard so that no queen will be attacking other queen. So this is the n-queen problem statement. So these all come under the state space search algorithm. So by using state space search algorithm, we can solve these types of problems and also any problem can be solved. So these are the main examples of the state space search problems. So in the state space search algorithms, so generate and test will be the basic level algorithm. So in this particular technique, we will generate a particular solution and we will see whether that solution is the best solution or not, or it is the solution so in which the goal node will be reached or not. So we will check that particular task in this generate and test. So this generate and test example will be the, so British Museum search problem. So in this particular in the British Museum, so the problem statement here is we have to find an object without following any procedure. That means we have to find an object by randomly roaming around the museum. So without any information about where the object is, so I have to roam this particular museum randomly and I have to find the particular object. So this is the problem example for the This is the example for the generate and test. The algorithm of the generate and test will be, so here we will be having two cases, that is, so generate and testing. So first we will generate a candidate and we will check whether that generated candidate is a solution or not. This procedure will be continued until so no more candidates exist. So that's why this was kept under while loop. So while more candidate exists, and that means we are having more candidates until we are having some candidates, we will do this particular 2 and 3 steps will be repeated. So second step is we have to generate a candidate, and third step is we have to test whether the generated candidate is a solution or not. So this is the simple algorithm. So the challenges faced in this generate and test are, so whenever we are trying to solve some complex problem, so then this particular algorithm will be inefficient. By using this generate and test we can get the solution, but we have to, so it will depend on the probability of the particular search space. That means we are having a more exponential search space means, so this particular algorithm was inefficient. So this generate and test algorithm was considered as high level algorithm. That means, so we will try to improvise this generate and test algorithm to have our, so whatever the basic condition is there, we have to try to get that particular solution. So to improvise whatever the generate and test algorithm is doing, we have to do, so what are the, how to generate an candidate. So for that particular question we will see here, so move gen function. So this move gen function is the function which it will take an input as some state, and it will generate whatever the reachable states from that particular move gen state. So S to G, so this is the simple example we can see here. So to know more about the move gen function, so move gen function is the function which will give the reachable states for that particular state. So that means, so for example, if I am giving here, so move gen of S, then the output of this particular function will be, so for S what are the neighboring or what are the adjacent vertices is, so A and C. So for the move, if the move gen function is applied on S, then the output will be, so A and C. So similarly I can apply any state as the input for this move gen function. So for example, if I am giving, so again I can give, so A. So if I am giving move gen of A, so what are the reachable states from A? So from A the adjacent vertices are S, B and D. So the move gen function of A will return S comma, so this move gen function of A will return S and B and D. So these are the output for the move gen function of A. So similarly, whatever the state we are giving, we are applying move gen function on that particular state means, so what are the reachable states from that particular state will be the output for that for the move gen function. So and also, so second one, in generate and test we are having second one is the, so checking whether it is a solution or not. So for checking the solution we are having, so two different functions, that is goal test of state, and also we are having goal test of state comma goal. So this particular goal test of state, so it will give true. So if the particular input state is goal state, it will give true, otherwise it will give false. In generate and test we are having two simple steps. First one is I have to generate a candidate. So we already seen how to generate some new candidates using move gen function. So similarly we have to test whether the generated candidate is a solution or not. So for that one, so we are having two different functions. First one is a goal test of state, and the second one is a goal test of state comma goal. So for that one, so first one, that is goal test of state. So it will return true if the particular whatever the input state is a goal state, then it will give true, otherwise it will give false. So second function, that is goal test of state comma goal. So here the arguments are the inputs for this function is, so some state s and also whatever the goal state, we have to give both. So it will true so this particular state. So the second goal function is goal test of a state comma goal. So this particular function will return true if the particular whatever the state we are given, if it matches to the goal state, so then it will give true, otherwise it will give false. So these are the basic functions that can be applied so to improve the generate and test algorithm. So move gen and also goal test. Thank you.
Like, share and subscribe. Hit the bell icon for more updates.